Good. So as we approach this problem, this day number 2, we're still going to be solving algebraically. We're going to use substitution. Remember, there are more than one way. You can always guess and check. That always works. You could graph all these. You can make tables and try to find the answer that way. But what we're going to look at today is how to set up and solve practically this situation. So in one day, the National Civil Rights Museum in Memphis, Tennessee, admitted 321 adults and children total, and collected $15.90. The price admission for $6 for adults and $4 for children. So how many adults and how many children were admitted that day? So what we're going to do is set up some equations based on different units. Notice one of the units is going to be in dollars. It's just how much money that was earned or was brought in. And the other unit is the number of tickets. Okay, so what's the first unit? The first unit is about dollars. So if we recall, it costs $6 for an adult ticket. So I'm going to use, underneath here I'll say, define my variables. A is going to be the number of adult tickets. And then B will say the number of children tickets. Now notice, if I take the $6 and multiply that by A, that'll tell me how much money was brought in by the adults. When I take the 4 and multiply it by the B, that'll tell me how much money was brought in for the children. Okay, so that looks like this. If I say $6 times the number of adult tickets plus $4 times the number of children tickets, and you could use C for children, maybe that would be more logical. And I'm going to say in the end, that's going to bring me in $1,590. So notice that each of these are dollar signs. This right here is a dollar sign. You don't need to write that in. That's a dollar sign, and that's a dollar sign. Okay. All we have to do here is we're going to say the number of adult tickets plus the number of children tickets is going to give me the total number of tickets sold. So if we take a look at the first one and we just subtract, or excuse me, the second equation, and we subtract B from both sides, then we now have A is equal to 321 minus B. Now notice that I'm putting the minus B here, and some people say, oh, can't we say negative B plus 31? That's true, but it actually doesn't matter ultimately which way you do it, because it doesn't talk about form. It doesn't say leave it in slope-intercept form or something like that. All right, so if we go through, step number 1, the big step number 1 is to solve for one of the variables. Great. Now I'm going to take that and I'm going to plug it in to the other equation. So 6, but instead of the letter A, I'm going to put 321 minus B. Plus the number of, or plus how much the tickets cost, or the total tickets for children, is going to give me the total price there. All right, I'm going to run out of space here, so I'll go on the side a little bit, but I distribute across the board there, 6 times that, 6 times the negative B. And we bring down the 4B. And bring down the 1590. All right, I'm going to do 2 things at once. I'm going to combine my like terms, and I'm going to move the 1926 to the other side. So combining like terms gives me negative 2B, and over on the other side will give me negative 336. Now all we do is divide by negative 2. To get positive, oops, that should be a 2, and 21. So what are we saying? We have 21 children tickets sold. So now we plug that back in, So A equals 321 minus 21 is going to give me 300 adult tickets. We do need to go back and make some changes here. So it's not 21 there, not 21 there, and not 300 there. Go. All right, so 168 here. Now I have 168 there to get 153 there. Good. Now notice that if we were to consider what our answers are going to be, that we would expect to not get, since we're talking about the number of people that were admitted, we're not going to get 2.5 children. We're not going to get 4,001/10 of a kid or something like that. We're always going to get whole numbers. In fact, we're not going to get any negative numbers because you can't have negative children or negative adults. So we expect anywhere from 0 adults and 400 kids to 300 adults and 0 kids. But all whole numbers, no negatives there. So I'm saying that I have 153 adult tickets and 168 children tickets.